Hey guys, so today we'll be discussing a very intuitive question. This question was asked during the Goldman Sachs interview round, and the reason I picked it up is because this question is actually a gold standard. So first, let's get started and discuss the problem. Now you're given two array, okay, array 1 and array 2. Both of these arrays are in a sorted fashion, okay. That means the elements are in an increasing order, and same thing applies for the array 2 as well. Now what you need to eventually do is that you need to return the same array 1 and array 2, but now the only difference is that you need to rearrange these elements such that the array A1 now represents the smallest n elements but in a sorted fashion, and the array 2 now represents the largest m elements, but even they are in a sorted fashion. Okay, so this is what the question is asking us to do. Now, for those folk who have not understood the question, let's just say that you have a new, let's take a new array, okay, new array of n plus m elements. Now, let's say that you start filling this elements over here. You fill all the array 1 elements over here, okay? You start filling all the elements of array 1 over here, and then you fill the remaining m elements of array 2 over here. Now, let's say that if you were to sort it out, if you sorted it out, this would come in a sorted fashion, obviously. So now what you need to do is that you need to take this n elements, starting n elements, and put this in array 1, and you need to take this array m and put this in array 2. That's what you're being told. So obviously you might be thinking that, hey, didn't I just give you the solution? But understand, I'm making a video. I usually don't make a video unless the problem is very intuitive. So there must be a reason behind why I'm making a video about it, right? So let's get started and understand that what is the twist about this question. So the twist about this question is that we have to use O of 1 space complexity. We have to use O of 1 space complexity over here. So this makes the question super difficult now, because earlier what approach which I had proposed is that we could have used an n plus m array and sort the elements and just return it out. But now the question says that we have to use O of 1. So you will be like, okay, we will just start comparing. We'll use a start comparing. We will check one with other elements, then we will move ahead. So very trivial approach, very bad approach. But I will give you another constraint. You have to do this in n plus m into log of n plus m time complexity. This is the time complexity and this is the space complexity. Now come up with a good approach. Okay. So this is what the question was asked in the Goldman Sachs interview round. That is, you have to do it in place and with the appropriate time complexity. So actually now, I would have usually said that in every videos I just drop a small hint, and after dropping a small hint, I would usually recommend you guys to take a pause and then continue. Okay. So here also I will pause this. You can pause this video after I give you the hint. So the hint over here is that you need to utilize some not so famous sorting algorithm. Okay, you might have heard of insertion sort. This is pretty famous. You might have heard of merge sort. You might have heard of quick sort. Okay, and there are a couple of other also. There is radix sort, bucket sort, but there is very less known called shell sort. Okay, so in what we are eventually going to use is the shell sort algorithm. And actually not completely shell sort, we are going to adapt one method. Like merge sort में कैसा होता है कि we use divide and conquer वाला strategy. Shell sort eventually uses some gap method concept. Okay, it uses some gap method concept. So inherently what we are going to do is that we are not going to shell sort, we are going to use the gap method. So this is the first hint for you. So now you can take a pause over here and then think that how we can use a gap method over this question. So I will start beginning now. Now let's say that how we are going to approach this. Let's say that there is a variable, arbitrary variable called gap. Now what we are going to do is that for simplicity, let me draw two arrays for you. Okay, let me draw two arrays for you. Now let's say that this whole array, and this is array 1 and this is array 2. Now for simplicity, let's say that if we are just place them side by side, just assume that they are a single array now. Just in your mind, not physically, just in your mind, say that they are in a single fashion order. So what this gap method says is that you construct a kind of a sliding window, you can say. And what you do is that you compare the ith element with the ith plus gap element. So let's say that this was the ith element over here. Then you compare with ith plus gap element. Okay. So this is how the question goes. So what you do is that you run the comparison, you compare I and I plus gap, and then you check which one has a greater value. Now, tell me one thing. If the value at the ith plus gap was something like 100, okay, and the value at the ith was 2, does it make sense to swap this one? Because let's say that ki not even swap, do you think that order is correct or not? Okay, because obviously 100 should only appear after 2. It makes sense. Okay, now let's introduce some other example. Let's say that this was 10 and this was 20. Okay, this was 10 or this was 20. Do you think it would make sense to put 10 over here and 20 over here? Okay, no, it would not make sense. And I think so I confused you over here because you might question me that ki, hey, didn't you just said that this is in a sorted fashion? Didn't you just said that it's in a sorted fashion? And why do we need to exchange over the elements from the same side? Okay, I will come to that. But before that, I will tell you to hold your horses before I come to the actual implementation of this algorithm. So the question inherently talks about the gap method where we just compare the ith and the ith plus gap element. Okay? Let's say that during the sorting, what we are going to do is that there can be any arbitrary number a1 and there can be any arbitrary number a2. We're going to check if a1 is greater than a2. Okay, we are going to check if a1 is greater than a2, then a1 is the more appropriate candidate at ith plus gap position, है ना? And a2 should be put back. So this is what the gap method inherently uses. And it does not stop here. It works like a sliding window concept. Okay, first you compare, you start from the index 0 and you check the 0 plus gap. Okay, and then you keep sliding it out. You keep sliding it out. You keep sliding it out. Now what might happen over here is that you might end up in a case where your sliding window will just shift towards the element on the right hand side. And obviously you would have told me that, hey Aniket, didn't you just say that let me imagine this in a single array? But I just said in the mind. But when we are physically solving this question, what can happen is that now you need to compare the elements from the array of array 2 and the array 1, and now you need to take a decision. If the elements, let's say that it was 200 over here and it was only 100 over here, then no exchange is required. But let's say that some heavy value is there, some 1000 value is there, okay, and some 200 values there, okay, and then we start comparing. Then it would have made more sense that we put 200 on this side and 1000 on this side. Okay, it would have made more sense on this side. So now I will come back to this. We will just continue our sliding window and we will continue till we reach the end of this given array 2. I know that's how we're going to solve this given question. So you might ask me that, hey Aniket, didn't you just said that array 1 is in a sorted format, array 2 is in a sorted format? But try to understand one thing. When you swap the elements, what might happen is that some higher elements from this side, some higher elements from this end can go over here, है ना? Some higher element can go over here, and it can disturb the ordering on the right hand side, है ना? It can disturb the ordering on the right hand side. Now same thing applies for the left hand side array also. Now let's put a gap method over here. When you swap elements, okay, what you do is that now, since let's say for a given example, if you had swapped this element over here and some element, let's say I'll talk this thing, okay, I'll for basic thing I'll talk this thing 1000 and 200. Let's take this for an example. Now let's say that you have swapped it, you found that 200 is a more appropriate candidate on the left hand side. Let's say that we put 200 over here, and let's start deleting 200 from the right hand side, and let's put 1000. So let's put 1000 over here. Let's say that now if I put 1000, okay, so what might happen over here is that we have done the swapping, but what might we might done is that we would have inherently broken this sorted fashion of this array 1, है ना? We might have inherently broken this thing. So we might need to so that's why we need a gap method again on this array 1 itself. So when we are comparing like this, we can check that, okay, we can maintain the ordered fashion. So that's why I'm not going totally into deep dive of this gap method. You can eventually check out the shell sort algorithm if you're totally interested. But otherwise, now you know why it makes sense that since we are swapping the elements out of the array 2 to array 1, the ordering fashion will eventually get disturbed in array 1. And that's why gap method is run in this array 1 and combined in array 1 and array 2 and combined in, singly in array 2 as well. So that introduces us the concept of gap method. Now I just said that we are talking about some arbitrary number over here. There is some arbitrary number over here. I've not disclosed what is the number, but for given example, let's say that the gap was very large. Gap was very large. Let's say that. Okay, now what might happen is that if the gap is very large, from the starting itself, you would have started to compare the element on array 1 and array 2. Okay, and then we would do the sliding window kind of approach, right? And then what now? Okay, you might tell me that what now? So using this gap method, what it eventually does is that all the larger elements, which lie on the left hand side, eventually gets thrown on the right hand side. Okay, so this gap method actually does this. Okay, and what we do in the next iteration is that we reduce the size of the gap by half. We reduce the size of the gap by half, and then we try to rerun this algorithm. Okay, and we keep reducing the size of this gap again by half, and then we keep running this algorithm over here, and again we keep reducing this gap over here. Okay, I'll tell you the how till what point we'll keep on decrementing the gap. Okay, and once the gap eventually reaches, if there is no gap, eventually the gap reaches 1, then it actually, after 1, it does not make sense to run this gap algorithm, because after that you decrement it, or we do certain operation, we are not going to run this algorithm. So let's say that for this problem, what the gap is, the gap is the ceiling. This gap is the ceiling of n plus m. Okay, the gap is the ceiling of n plus m. So I'm going to write the formula for you. So the formula is ceiling of n plus m. Okay, let's say now it is what? It is very straightforward. ठीक है, 5 plus 4 9, 9 divided by 2 is 4.5. 4.5 का ceiling लेंगे तो 5 आ जाएगा. ठीक है, so the gap becomes 5 over here. And every time what we do is that we are going to keep reducing the gap. We are going to keep dividing the gap, and now then try to solve this problem again. So eventually what happens is that at the end of the day, all the elements get sorted, and since all the elements eventually get sorted, and there is nothing much we have to worry about. So that was all about the gap method. Okay, I had explained over you, and let's go to the code and see how does it work. So as I had told over here, we are taking the ceiling, right? We are taking the ceiling. You can use this n plus m plus 1 wala approach, which ensures that you are eventually dealing with the ceiling with the high. Take it. We are not going flooring down the value. Now the next thing is that, as I told you, that we might need to run this algorithm multiple times until the gap is not equal to 0, like it is greater than 0, you can say. Okay. Now I had explained you that we are going to start from ith is equal to 0 again, and ith we are going to check for the gap element. So initially, let's say that I is 0, and what will be the j element represent? What will be the j element represent? J element will represent ith plus gap, and since I is 0 initially, so it will just say 0 plus gap. So that is why we are writing gap. Now we need to run this algorithm till what point? So it makes sense, right? Until our j is less than equal to n plus m. Okay? This is the condition till which we are going to run this algorithm over here. Because what we are eventually doing is that, okay, you might tell me that, hey, what is this thing, dude? What is this thing? Aren't you confusing me with this thing? So just say for a simplicity purpose that ith and j are just initially some elements. So, okay, we have defined ith and gap. So what might happen is that as we move ahead, the value of this thing will also change, right? So the value of j will also change, right? Because we are eventually incrementing it. So what might happen is that it might go out of bound. Till what point it will go out of bound, I'll discuss over here. See, didn't I tell you that we have to work it like a sliding window? So obviously we will run this sliding window. Think like this. J is just the right pointer. Think j is just the right pointer. Actually, it makes more sense if you take this as a right pointer. And we're going to run this algorithm till it is less than n plus m. So now do you think it makes more sense that you can change this to start, and you can change this to start and then left to right? It actually makes more sense over here like that. Okay, because what I am inherently telling you is that treat both these array as a single array, you know, logically. But when you're trying to do some manipulation, now you need to do some conversion back. Okay, now all of this operation is just for this thing. Now, as I had said you that first you need to run this algorithm on the first array one, and then you need to run this algorithm on then you need to check that have we exceeded that. Okay, I'll give you one more good example where we can show you that. Let's say that key now we are let me just copy paste this thing. Okay, it does not allow me. Okay, I'll draw a new one. So what might happen is that, key dude, we might need to take some extra precautions over here. Why precautions? Because what might happen is that, let's say our gap was running here. Okay, we started from this point. We moved over here. We moved over here. We moved over here. At this point, a jth will have exceeded it. Okay, a jth will have reached the end of this thing. So now we need to shift our j. We need to write some logic such that the j, since what was our j, or what was our right? Our right was representing the value over here. Now we need to, once we shift it, what might happen is that if we try to assess any value after right, we might need to go and ask the array2, hey array2, what is the value of this position? So we might need to do some manipulation or like subtraction to get some values, which I will show you in the code. So for now, let's say that what we are eventually doing over here is that first, simply to explain you, we are going to run this gap method on the first array itself. We run this gap algorithm on the first method. After that, if we reach a case if where j becomes less than n, where j becomes less than n, then we are going to run this algorithm till j is less than n. And once it exceeds n, what is n over here? N is the size of this thing. So just think that you are running the right algorithm till this point. After that, what happens is that we know we have started to exceed, so it will come over here. Okay, what might happen is that this j will come over here. So now we need to write a logic. We need to write logic to parse this thing. So we are going to run till which point? Okay, it obviously makes sense till our left pointer will allow. Okay, our left pointer is this thing. Okay, a left pointer is this thing. So we need to run till this left pointer will allow. Until what point we can do the comparison? We can do the comparison till this point almost. So that's why we are writing I is less than n. Okay, and obviously there will become another constraint that j should be greater than equal to n. Obviously this, so that's why we're writing some if else if conditions, right? Because पहले condition में तो कोई constraint नहीं है, पहले condition में कोई constraint नहीं है, because we just need to rely on the j. And but second में constraint क्या हो जाता है ना कि your right pointer should be greater than n, तभी तो second array पे fall करेगा, and your ith will be somewhere over the left hand side, है ना? Right now I just shifted this array, but your ith will be somewhere over here and jth will be somewhere over here. So j should be less than should be greater than n. ये तो क्लियर कट दिख रहा है. अगर इसका साइज n है तो ऑब्वियसली बात है कि j जो होगा एटलीस्ट ग्रेटर देन n होगा, है ना? दैट्स व्हाट द क्वेश्चन इज सेइंग. एंड वी नीड टू डू सम कंपैरिजन ऑपरेशन आल्सो. तो ऑब्वियसली अगर तुम यहाँ पे किसी भी एलिमेंट को रिप्रेजेंट कर रहे हो तो कैसे रिप्रेजेंट करोगे? ठीक है, सेम थिंग, j माइनस n कर दो उधर और तुम्हें array 2 में इंडेक्स मिल जाएगा उसका. मतलब अगर राइट पॉइंटर अगर रिप्रेजेंट कर रहा है या तो एन रिप्रेजेंट कर रहा है, व्हाट यू कैन इवेंचुअली डू इज दैट यू कैन से दैट दिस इज j माइनस n. एंड लास्ट थिंग इज दैट both pointers on the second array. अब क्या हो सकता है कि now what can happen over here is that कि let's say that you completed running this algorithm. Now this algorithm will start running on the second array itself. So that's how the question goes. So you need to calculate the gap again and again. So just ensure that this is calculate next gap logic. I'm not going to explain you the approach. And जैसे गैप की वैल्यू 1 हो जाती है तो जस्ट ब्रेक आउट ऑफ द कंडीशन. देयर इज नो पॉइंट इन रनिंग द, बिकॉज गैप क्या बोल रहा है कि उसके बाद कुछ बचा ही नहीं कंपेयर करने के लिए. ठीक है, if we just break out of this loop and we just exit it, and ये जो गैप वाला लॉजिक है ना, करंट कैलकुलेट द नेक्स्ट गैप, तो ये क्या कर रहा है ना कि इट्स जस्ट टेकिंग द सीलिंग वैल्यू, इट्स जस्ट टेकिंग द सीलिंग वैल्यू. नाउ व्हाट इज द इवेंचुअल टाइम कॉम्प्लेक्सिटी ओवर हियर? सी, जो इंटरनल ऑपरेशंस हो रहे हैं n प्लस m टाइम रन होंगे, ये n प्लस m टाइम रन होगा. बट जो आउटर वाला है वो हमेशा n प्लस सॉरी गैप का डिवाइड बाई 2 हो रहा है. इनिशियली हम लोग चालू कर रहे थे किससे? गैप n प्लस m डिवाइड बाई 2. तो इवेंचुअली जो उसकी टाइम कॉम्प्लेक्सिटी आएगी ये लॉग ऑफ n प्लस m टाइम रन होगा, और ये जो अंदर वाला लूप है ना वो रन होगा n प्लस n इंटू लॉग ऑफ n प्लस m टाइम. So that's how the gap algorithm works. See, I'm not going in deep dive into the code. Code is just a representation of your thought. अगर आपका thought process clear है, आपको पता चल रहा है कि gap method कैसे run हो रहा है, then it's pretty straightforward question. So I hope you enjoyed this video. Give a like, thumbs up, share with your friends, and see prepared for the interview. I hope you make it. Thank you. Bye.